This is lesson 20 for 7th grade, and as you can see, we were pretty busy today. We were covering 3 topics: exponents, rectangular area, and square roots. Today is kind of an introduction to all these things, and we'll be getting into them deeper later. And I'm willing to bet we'll be spending more time on this tomorrow. Kind of seems that way, just so we make sure we've got a handle on everything that's being presented today. So we're going to start with exponents. And the first thing that I started off with was, what does 2 to the 4th power mean? Well, it actually means we're going to take 2 4 times and multiply it. It actually equals 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th means 2 times 2 times 2 times 2. Now, the thing about this is we have a common mistake. The common mistake is to take 2 times 4. But that's not what we do. Remember that it means 2 times 2 times 2 times 2. And what we really want to do now is show us, okay, what does 2 times 4 actually mean? We know that it equals 8, but what does it mean? Well, it's the same thing as taking 2 and adding it 4 times. So here's the big difference between exponents and multiplying. Exponents uses multiplication, but this does not mean 2 times 4. It means 2 times 2 times 2 times 2, where 2 times 4 actually means 2 plus 2 plus 2 plus 2 to get 8. So, that's the difference between them. Remember not to make the common mistake. See this? It means we are multiplying 4 2's together, or whatever base we may have. So, this is how exponents are set up, and we could see it on the previous example. Basically, exponents are repeated multiplication with an exponent. So our base here is 5, our exponent is 4. 5 times 5 times 5 times 5, so 5 to the 4th power, exponent, base. Alright, and these examples just show exponential expressions, some big words here. 4 to the 2nd power, we could say 4 to the 2nd power, or we could say 4 squared. The students are going to hear me say squared a lot, because a lot of what we deal with will be 2 to the 2nd power, so I'll be saying squared to save time. Anything to the 3rd you can say is cubed, so this would be 2 cubed, or 2 to the 3rd. And anything above 4 or above, we just use the number with the th. So 5 to the 4th power, 10 to the 5th power, 7 to the 18th power. So there we'll just use th afterwards. 2 and 3 have special ones, squared and cubed. So to start off basic, I had them answer, what is 5 squared, or 5 to the 2nd? Well, this means we're multiplying 5 together twice. 5 times 5. And we know that 5 times 5 is 25. So here's our common mistake answer. It is not 2 times 5, it is 5 times 5, and we get 25. So, just a nice one to start off with there. Here, 10 to the 4th power. Alright, we gotta remember that this means 10 times 10 times 10 times 10. Alright, if we do that, we could get 100 times 10 is 1,000, times another 10 is 10,000. The shortcut here is that we have 10 to the 4th power, and we have 4 zeros after our 1. So that would be 10,000. Alright, now this one, this is 2 to the 2/3 squared. What do we do there? Well, nothing changes with the fractions. This rule still applies. This means 2/3 times 2/3, which we know will be 2 times 2 is 4, 3 times 3 is 9. So we should be looking at 4/9 there, and we should be getting number 2, 4 over 9. Alright. Okay, now if we simplify this expression, 4 to the second, or 4 squared, minus 2 to the third, or 2 cubed. 4 to the second is 4 times 4, minus 2 to the third, 2 times 2 times 2. Alright, so 4 times 4 is 16. 2 times 2 is 4, times another 2 is 8. We should have 16 minus 8, which should give us 8. Alright. Okay, moving right along with these examples. Now this one's a little interesting. What is the missing exponent? So 2 to the third times 2 to the fourth equals 2 to the what? So we're looking for that n there. We have special rules with these exponents, which we will get into more detail with later. Basically, let's think about the definition of what exponents mean. 2 to the third means 2 times 2 times 2. And 2 to the fourth means 2 times 2 times 2 times 2. Alright? So we have all of these 2's being multiplied together. How many do we have? Well, we've got 1, 2, 3, 4, 5, 6, 7. 7 2's are being multiplied together. So that actually means 2 to the 7th power. So n would be 7. So this is actually 2 to the 7th. In the future, we're going to find out that when we have this situation, we can just add these two exponents, 3 plus 4, to get our 7 right there. And that will be a future lesson. This one's a little different. This is 2 to the 6th power divided by 2 to the 3rd. What's the missing exponent going to be here? Well, let's write out 2 to the 6th. 2 times 2 times 2 times 2 times 2 times 2, 6 times, all over 2 to the 3rd, 2 times 2 times 2. Alright, now in this situation, everything's being multiplied up here, everything's being multiplied down here. We can do our dividing, or we can just cross out this one, this one, this one. Pairs of 2. And we're left with 3 2's on top. So n here would be equal to 3 here. Sorry, that would be 3. Okay. And as we'll find out in the future, our shortcut here would just be 6 minus 3, and we would get n equals 3 there. That's our shortcut, which we will talk about in the future. I'm going to check my time quick. Alright. Got plenty of time still. Alright, so the reason they're introducing rectangular area here is that once we start multiplying units, the units actually change exponents. And I'll talk about that in a second. Basically, when we're looking at area, we're trying to figure out the inside. How much is inside? So here we'll be looking at square footage. That's very typical for a house buyer or something like that. This is a square foot right here, a 1 by 1 foot square. So how many of those fit into this 4 by 8? And we'll see that we can take a shortcut with our area in a second here. If we counted up all these, we would get 32 square feet, or 4 times 8 is 32 square feet. Now the big idea here is that it's important to note that units change when we multiply or divide, but they don't when we add or subtract. So we're going to show this in a second here. When we were talking about perimeter yesterday, our units did not change when we added everything up, but they will change when we multiply and find area. So here are two of our areas here for a square and a rectangle. Area of a square, side times side, or area equals the side squared, S times S. Area of a rectangle, length times width. And both of those formulas are in my room, and the students can use those to their advantage, even on a test. Alright, perimeter and area of this rectangle, a 3 by 5 rectangle, inches. So perimeter, remember, we just distance around, add up all of our sides. 5 plus 3 plus 5 plus 3. We should be 8 plus 8, 16. Now we're adding, so our units will not change, we're just going to stick with inches. Area, that is our length times width, and that would be length times width, 3 times 5, but, or it'd be more so 5 times 3 if we follow the formula here. 15, but it's 3 inches times 5 inches, this will be inches squared. So remember, when we multiply, our units do change. So that's the difference there with those. I'm going to check my time again. Alright, we're getting close. So I'm going to speed up a little bit. Go through our next example. Alright, the perimeter of a certain square is 24 meters. What is the area of the square? Alright, so for area, we know we need length times width. We have to find out what our length and width are. It's a square, so length and width should be the same thing. So we have a square, and we know the perimeter is 24. So distance around is 24, and all of these sides have to be the same. So 4 sides that all have to be the same. 24 divided by 4. Oops, jumping the gun there. Alright, 24 divided by 4 is 6. So we know that's 6 meters, 6 meters, 6 meters, 6 meters. And length times width, or side times side, side squared, this will be 6 times 6, which is 36 meters squared. Since we are doing area there, we have to be in square units. So, should have got number 3 there, 36 meters squared. Alright? And a very brief introduction to square roots. We've been talking, adding and subtracting, they are inverses. Multiplying, dividing, they are inverses. While squaring a number and taking the square root of a number, they are inverses. So very briefly here, for instance, we know that 3 squared equals 9. 3 times 3 is 9. So the square root of 9 is 3. It's kind of going backwards. The square root of 9 is 3, since 3 times 3 equals 9. And we would write that like this. Square root of 9 equals 3. So, I want to take a look at these, check my time once again. Got about 2 minutes, and this is my last example here. Okay, so basically what we're looking for here is what to the second power equals 121. That's going to be our solution to this. I know this one by heart because I've been dealing with these for a long time. And I know that 11 times 11 equals 121. 1, 1, 0, 1, 1. We add those, 1, 2, 1, we get 121. So, since 11 squared equals 121, this is 11. Now, for B, here's the long way to do it. 8 squared is 64. So square root of 64, we're looking for that. Basically we're saying what squared equals 64. Well, 8 squared equals 64. So I know 8 goes in there. This has to be 8. So, remember when I said that squaring and square roots are inverses? Well, you're square rooting something that's being squared. So your shortcut is to just say, okay, cancel those 2 things out and you're left with 8. Alright, that's a very basic intro, and we're going to cover more of this tomorrow, and the homework should be on the way. Thanks.